Okay, so I'm Toby. I'm just going to sort of wing some C++ code. So I apologize in advance. I'm not super prepared for this, but yeah, we'll just play around with some C++ code. What I've got in this file I'm looking at is the Haskell Prelude, or part of it. So I'm just going to run up some C++ code that does a similar thing. It's not going to be exactly the same thing. I think C++ is just never going to be Haskell. And kind of the point of this is just to show off, or possibly expose, some of the features in C++ which have been added recently or will be added soon. So what we've got on the screen here on the left, we've got some C++ code. This is an online compiler thing called Compiler Explorer, which is pretty cool. So it's going to come up with, well, if I actually put the code into it, it'll show the generated assembly code on the right, and the compiler error messages as well. So, okay, so the Haskell Prelude starts with class EQ for whatever reason. This jumps right into something that's really awkward in C++, because it doesn't really have anything exactly the same as Haskell's type classes. It has classes, but it's quite a different thing. What I've got, I cheated with this and typed it up on the train because I would not be able to write it correctly first time. So the way this kind of thing, so for those of you who don't know what Haskell type classes are, just briefly, so this Haskell code in common here that defines a type class called EQ. It says a type A. If a type A is, I don't even know the terminology in Haskell. But anyway, if you've got a class type A, then it is in class EQ if it's got the operations equals, not equals, that take two A's and give you a ball back. So the way this kind of thing is normally done in C++ is with traits. So, well, it's something like traits. So what I've defined is a struct template that has no definition. So this essentially says any type called A doesn't have an EQ impl, and later on we can add impls of EQ for certain types. So then, just for fun, using a feature that's just recently been added into the C++ draft standard. So we're defining a concept called EQ, and this says that for type A, it satisfies the EQ concept if given x and y of type A, the instance of EQ impl for A has a function called EQ, which takes those two values and gives you a bool, and has an EE. I've used those names because it's inconvenient to use operators there. So then in the Haskell, there's a default implementation which says not equals is defined in terms of equals, and equals can be defined in terms of not equals. So you only have to define one. So we can do a similar thing in C++. So we can make a default implementation. So we can define EQ as not EE, and EE is not EQ. Then we can define some the operators that stand alone. That just makes it more convenient to use this stuff. So we've got the equals operator, and C++ uses the band equals or the slash equals. And what they do is they just delegate to this EQ impl template. So we're relying on there being specialization of that template for that type A. So the rest of the code is going to be out because it failed to compile. So let's start by defining simple type for S. This type doesn't have anything. It doesn't have an implementation of EQ defined. So if we write this static cert that we're comparing two instances of it, we're trying to compare two instances of these things. The compiler complains, no match for operator equals operating types, blah blah, because whatever goes on and on. So that's expected. So to make S a quality variable, we have this specialization of the EQ impl class template, and it inherits from the default implementations, and it just defines EQ. So this just says given two S's, they are equal. So the simplest possible version. So now,
do the empty angles mean it's inferred, or is it
the empty angles means this is means it's a complete class, complete template specialization for the class.
So there's nothing left to parameterize over.
So yeah, please do interrupt me with questions and heckles and things, because I don't have a lot prepared. So. Okay, so now this code is the same as what we had above. Now that compiles. So static assert is quite a cool feature of C++. It evaluates that expression at compile time, which is why I've put this const export everywhere. Otherwise, I can't use static assert, and I'd have to actually compile and execute it and run it. But yeah. I just wondered, does it still compile if you take out the definition equals? This one. It does not compile. It does not compile with an interesting error message. So the compiler goes into an infinite loop. It gives up eventually. Down the bottom of the page, it says evaluation depth exceeds the maximum of 512.
Because of assumption, if you don't have any assumption, it will compile the type.
Yeah, it would compile just fine because it's going to fail in the next one. If you don't have those assertions, then it won't even generate any of that code. Because you're not instantiating the templates.
Yeah, but I think that we can write the product as usual, and then we call
yeah, then it would go into an infinite loop runtime. I prefer infinite loops in my compiler. Yeah. So it would quickly exhaust, hopefully exhaust the stack, unless it did tail call optimization. So that would be a shame.
Tail call optimize your stack overflow.
So what's the? Oh yeah. So I put this here just to show that we can actually get some. Oh look, that's the assembly for that infinite loop we were just talking about.
Some assembly that's easy to understand.
That's about the extent of my ability to understand. So if we put that back, then it changes to return 0. Oops, we got to type that. Anyway, that's quite cute. So that was jumping right into really annoying stuff for C++. And now we can do. Okay, so the next thing is just the ORD class, which kind of extends the EQ class. So something with EQ that can also be ORD. Well, yeah. Additionally, you can make it ORD. So we can define a very similar thing. This ORD class is quite large. It's got like a whole lot of functions in it, which is kind of annoying. But the minimum implementation is just this stack, and all the rest can be So that's what this code does. Same pattern. We define our class template. So the interesting thing here is this has a constraint saying that all impulse can only be defined for things that satisfy the EQ concept, which is kind of nice if you try to make an order for something that's not also EQ, you get your message saying that. Kind of saying that, you know how to decipher it. So anyway, this is just a whole lot of code which I typed out, and I'm not that interested, to be honest.
Does it requires being part of a language? Or?
It is part of the current draft of the next version of the language. And the syntax I've got here is not exactly the same. The syntax I'm using here is part of the concept's technical specification, which has been published for a few years. But the version that's currently in the standard is slightly different. Anyway, so yeah, this has much the same stuff. So here it is. I'm going to skip over quite a bit of stuff. The Haskell Prelude, for whatever reason, defines things in what it seems to me is like order. So I'm going to skip over enumeration classes and numeric classes and numeric functions because they're not that interesting in C++. So, trivial type. So Haskell has this unit type, which apparently can't be defined in legal Haskell. According to this comment, but so there's a few options in C++ for this. You can go you can make an empty struct. So this is something that of course that's not quite good enough because then you have to define EQ and origin, boundary and such for that. So that struct is not very useful because you can't compare it to itself. You might not want to. So that's one option. Another option, given C++ 17, no, 11, sorry. Okay. C++ 11, you can make a tuple of 0 elements, which is much the same thing, but the advantage of that is that it gives you comparison operations for free. So this using is just a type alias. So that's the one I quite like to use, but other people like other definitions of that. You can probably come up with a number of different things that act like the unit type. Yeah, sure.
Because it's then a tuple, the empty angles again. If you want to have 2 or 3 elements in Haskell, you would have different data type for each of those.
Yes.
Does C++ have anything at the language level to alleviate that, or would you call tuple 2, tuple 3, tuple 4 to get like?
No. So tuple is a variadic template. It can take any number of 0 to many template arguments. So you can have
so bad in unit that they wouldn't be able to compare.
No, they are different types.
Yeah.
Okay, so now what seems more interesting to me is some actual functions. So ID, the identity function. So I guess the interesting thing about that in Haskell is it can take any type overall and returns the same thing. So in C++ you normally use a function template for that. So we can write just write class. So we can write the simple function template. Takes an object of any type, returns it. And that kind of works, but I don't like it because you can't then pass that easily to some other function. So let's say we have another function, and I wanted to pass it an int and a function, and then I wanted it to call that function with that int. I would not be able to call through with the identity function that I have just defined, because ID is not a function, it's a function template. And due to the way C++ works, you have to tell it what type you want it, which is obviously pretty crappy. and sort of defeats a lot of things. So,
if you have made bar a separate function as well, can you pass down the first driver?
yeah, sure, but then you still need to specify it.
Specify further on.
So the way I like to get around this is like this, and then that doesn't compile anymore because that's not a template anymore, and that and that's because ID there is actually an object. It's a closure essentially, and it's equivalent to if we've written etc. Sorry, lots of typing in should have considered this. So it's kind of like this. So that but
The question, so that line 1 and 7, that's why we go together again. Can that expand to multiple functions of different types, or do you only find it one thing?
So that ID is an object that has a templated function called operator on it. So you can call it with different types. So, for example, because food is int. Obviously, I can't call food with a different type. That's heavy.
So suppose you know that f is a function that you can call.
It doesn't. So if you were to call it with something that's not a function, then you just get a compile error saying, oh, you can't use that as a function.
And you get an error when you have a usage site. It's getting an error back on line 200.
Yes. So it tells you that here on line 200 is where the error occurred, and then it also tells you that here on line 205 is why the error was occurring there.
Is there a way to express in the type definition of body, in the type definition of food that needs to be a function?
Yes. there are ways of expressing that. You can do it with the concepts like I did before. I actually don't know how to do it. I haven't learned yet how to do that. What you can do is you end up having the right stuff like so now the error message you get is there's no matching function call for the intent because we can't create argument production, blah, blah, blah. So this gives you much the same result, but it ends up telling you down this line 205 is where the error occurs, saying there is no foo function that takes those types because this return type is low form. So you can express that much more nicely with concepts. Get down really.
Could you use the initial mechanism you showed to implement the applicative and then implement the function? Get around the type system using the templates provided by the structs?
Yeah, probably. It can get pretty nasty to express the types you need. Once you get too higher order, and usually, commonly, I give up. I just put auto and template this, and it still fails with compile time, but doesn't clearly express the type. But anyway, this is kind of what you end up with. You can kind of get there. So we're just talking about ID still. So another example, const. So this is kind of interesting, but it takes two arguments. So in Haskell, obviously this is curried, so we can write it that way, meaning that you call it with one argument and you get that another function that takes one argument. So we can write it that way in C++. So what we do is we have to type take. You are correct. So then we have to return another lambda that takes something. We can say that we can return x. So yeah, so this is probably clear actually. So yeah, so this is a function that takes one parameter and then returns a function that takes one parameter and then returns the original parameter that was passed.
One thing equals.
Hopefully we can notice that. So in C++ lambda expressions, you have to be explicit about the variables you're closing over. And the reason for that is because of object lifetimes and preferences and pointers and things. So the equals means anything that I use that comes from the outer scope, take a copy of it. So capture that value. So that might, well, in this case, that's really what you want, because otherwise you will crash. The other option is to do that, which is to capture it by reference. But this variable is going out of scope before anybody can call this in a lambda. So that in a lambda will capture a reference to a variable that doesn't exist.
So if the equals, you copy it.
Yeah. At the same time. So it might work if for example, this was a reference, but then it's up to the caller to make sure that the lifetime of that object exceeds the lifetime of this inner range, which is a pretty awkward API. So I prefer to take things by value when possible. So this would use so we could actually let's so we can return const 4 and then we can pass it 5 and hopefully we'll see that as returning 4. Yeah, it's 4 in the X and returns it. We can probably start with this as well. And then we could save those things away and call them later. Okay, function compositions. I'm just worried. Yeah. Well, I can go as long as you want. Yeah. So there really isn't much different because I did much further. So it's a perfectly good time to call it. Any questions before we go? Yeah. So which one?
C++.
Well, yeah. So that's GCC for you. Yeah. So
it was actually called closures.
Yeah. That is. So that's one of the reasons you might want to write this stuff in C++ rather than Haskell. If you want your, well, I mean, it's not really a very interesting use case to have a function that just returns 4. And I'm sure you can write a flash function that returns 4 in Haskell. If you try really hard, maybe. But yeah, all of the major C++ compilers can see through lambda expressions pretty well, and because there's no type erasure or anything going on here, so this const has some really complicated type which you literally cannot write down. That encodes all the information about these lambdas. So every lambda expression generates a unique type essentially. So that's yeah, it can all be inline and then constant expression folded. And this is a trivial example of that.
I was going to ask a sort of similar question, but I don't know too much about C++, especially when you but I was just wondering how efficient this stuff writing these kind of equivalent things are in C++. Because I know from lots of type systems you can do anything you want, but your compiler ends up doing all the induction and then users doing stuff. Does that happen here?
You're definitely going to work your compiler harder than if you were writing things with concrete types. I mean, I'm not really hitting on any of the stuff that's going to really blow up your compiler. Well, apart from the infinite loop, that literally blows up your compiler. But I mean, even that can fails to compile pretty quickly. Things can get pretty hairy when you get into some of the more advanced meta programming with templates, where you're generating thousands of classes just to calculate some value, and compile times can slow down a lot. That's one of the things that concepts is going to help with. Remains to be seen. But you're certainly working the compiler harder. If you're careful, you can end up with good runtime performance. Particularly if you want 4 is a good number. But 0 is also good. But yeah, I'll go that out.
So would that, if you were to pass const underscore 4, if you would call it with anything but if you were to assign it to a variable first, how long does it follow until it gives up or proving that something is not being mutated?
When you, instead of putting 3.5 there, you put quotes hello.
Oh, okay. That's just a point. Probably a bit of a difference. What would you use? I mean, what we could do is we could.
So let's say you put an object in there that could be mutated by reference, by dereferencing the. Right? If you were to pass a struct in, you could be modifying, like, it would need to track that const doesn't like
right
figure out where the pointer lives and change the memory because it needs to prove that 4 always has to be returned.
Yeah, well, it can do some. Its job is pretty easy because I'm passing everything by value, so it knows that these factors are getting copied. It could.
This is quite a recent version of the compiler for that tool.
This stuff, you need so generic lambdas, which is what these things are, auto parameters, those are a C++ 14 feature, so you need a compiler from the last few years. But yeah, as far as I know, they've been able to do that pretty well. So I got this right. I can't pass this to 4.
When you write those functions in Haskell, in the Haskell compiler, remove that function correctly, and then you can use that function call size over you want, just as it's a different data dictionary. So it feels like when you are doing that in C++, it actually does not remove that function when you define it. It's just like when you call that function with a specific type, it's trying to the function.
That's correct. That is pretty much the way it works.
So they are more like macro expansions than.
Yeah, it's kind of a cross between the two. I mean, if you've got out syntax errors in the template, you get errors in the template. But unless you actually use it with specific types, it won't catch type errors. Which is definitely a weakness compared to other languages. It's actually fixing that is something that was proposed way